So today I just thought we'd take a look at these rechargeable batteries sent to us from EBL, and they contacted me a while back about sending me these batteries to check, and I actually would love to do a capacity check on them and just see what we think about them. So let's get into it. It does come with a case, the owner's manual, it's printed well. It's only a few pages of English here. The rest is other languages if you're interested. Let's get right into it. We see here that we got 8 AA's and 4 AA's. So our charger is the EBL 6201 5-volt DC input, 2 amp max. It tells us that we can do 1 AA at 3600 milliamp hours, 4 at 900, 1 AAA at 1800, and 4 AAA at 450 milliamp. You can actually hook up USB-C as well as the USB micro. So it does come with the adapters for the C and the D as well. So the C adapter, it does work. It kind of pushes on through pretty easy. The D, I guess you just kind of push it. Yeah, you just kind of push it and it kind of locks in. The center connection there, the center pin. So we have 2 of these D's and 2 of the C's. If you did want to use these in a device that took C and D batteries, which wouldn't have a lot of capacity unfortunately, but it would get by in some cases. So I'm going to bring over this Opus BT-C3400 battery tester. This is a pretty decent intelligent charger and tester. As we see here, it'll charge, do charge test, quick test, discharge refresh, and discharge test. And I also do a maximum charging capacity of up to 20,000 milliamp hour. It does come with the AC adapter to run it. And let's get right into it. Going to go ahead and take these batteries to a discharge test. I'm going to set the current to the max of 700 milliamp load for the nickel metal hydride chemistry. And there we go, we're counting up a milliamp hours. We'll come back and we'll see how it does. Alright, a few hours later, these have completed their test, and this first test is a little disappointing. I expect it to be somewhat closer to at least 2800 milliamp hour, and we really didn't break 2200 milliamp hour. They are somewhat consistent here, especially 3 out of the 4. Very consistent, but consistently below 2200 milliamp hour. So just to make sure that nothing's wrong with my testing here, I'm going to bring over these in-loop batteries that I have, and if you'll look, extremely similar design here. As far as the case and everything goes, comes with its own charger, some adapters. This set is about 4 years old, so I'm not trying to compare apples to apples here, but since Interloop does claim that these have a up to 10 years useful life, and it can even maintain a charge up to 70% charge for 10 years, so I have a good feeling that these are more than likely going to still be a decent capacity battery. As we see here, these have the adapters. The C adapter does lock in a lot better. The D actually even locks, the little cap on the back locks in on the D on these. And we see that the charger here is older, but it's a plug-in type, and it's a nice charger. It does have a 5 volts 1 amp output for charging other things, but I do like how the EBL, you can actually hook up USB-C as well as the USB micro and power it from anything, even your vehicle charge if you wanted to, right? Got these charged back up here. So I'm going to go through now, and I'm going to compare the Interloop and the EBLs together here. So I'm going to let these batteries charge up, and while they're charging here, I'm going to go through and get a cell weight. I'll put this on a chart at the end of the video. We can compare them here, but 27.4 grams for the AA EBL. The Interloop is going to be 26.4 grams, so 1 gram less. but we're talking about a 1900 milliamp hour cell there too. The AAA is going to be 12.9 for the EBL, and the inner loop AAA 11.8, 11.9. I'm going to put a couple inner loop 1900 milliamp hours in here, this older, as well as the new EBL 2800s. We'll just go through the slot here until all of them are flashing and select them all and take the mode to discharge. I'm going to select the current to 700 milliamp load on this one. Yep, went past it, 700 milliamp. Yep. We can go through and look at the display here. And then if we hit slot, it'll actually start doing the test. And now our test is going. We won't take quite this long on the rest of the test, just going through here how this works, and we'll see our milliamp hours counting up, and we'll be back to see how these batteries perform. So back now. I mean, the inner loop did pretty well. To be as old as they are and closer to 1800 milliamp hour, and they're rated for 1900 when they were new. The EBLs, on the other hand, the highest I got was 2308, which I believe is the highest so far with the EBL. Yeah, rated for 2800. That's not really what I expected there. We're just barely getting what, 70-75%. We'll figure all this up in the end of the video. I'll do some charts and data points here as for comparison, but we'll see our voltage discharge level. Depending on when the test was over, they have bounced back a little, but alright, we'll recharge these and we'll put some more in here. This time we'll change the slots up a little just to be fair. Even though I've done all 4 EBLs in all 4 spots in one test now, I think all 4 channels are probably pretty accurate, but I'm gonna mix it up just to be fair. We're starting our test. We'll come back and we'll see how it goes. Well, it looks like on this go round we had around 1800 on these inner loop set as well, so the inner loop has been very consistent to be older cells, and still hitting on up. We'll figure it up over 90%, looks like, on your charge or your actual tested capacity versus your advertised. But again, the EBLs come up one short of 2100 and one just over 2200 milliamp hours, so still lacking there in the 70-75% of the rated capacity. This is our run time here of each. I'll collect some of this data and we'll have some of the best results at the end, try to chart it out and get a better understanding of what's going on with the data that we collect here. I'm going to go ahead and do a quick test here after these are depleted and just look at the what's the resistance like at the end of the discharge cycle of the battery, and I'll chart this as well at the end. And here's 2 different tests to compare to. Now I'm going to go ahead and we'll do the AAA batteries. We'll do the inner loop on the, let's do the inner loop on the right. We'll put the EBLs here, just fresh off the charger on the left. The inner loop's actually charged the day before, and the EBLs I'm just charging today, but since inner loop says up to 10 years on their charge, so I think we find the test a day old charged battery here. Make sure we got a good connection here to be fair. Let's go through. I want to select 500, I think, for the AAA. That's just what I'm going to select. Let's keep it the same on all to be fair. And here we go. We're timing and we're discharging, and we'll be back and we'll see how it goes. And while these are discharging, I want to share with you that I did run out to Harbor Freight. We've got a new local Harbor Freight opened up here in the area, and I picked up these AA and AAA Thunderbolt batteries for about $7.99 each. That's with no coupons or anything, just typical sale price, and I like to also include them, so we'll see how that goes as well. So here we go back with the AAAs for the discharged. Our EBLs, well, surprising, it's way on up in the high 90% of what they're rated for. It's very good. In a loop, rated for 750, so even though several years old, awesome. Pretty close to its rating as well. Both of those done fantastic. So now back with these Thunderbolts from Harbor Freight charged up, and I did use the EBL charger to charge these. And I'm going to do one set of AA's and one set of AAA's just to add a little bit more data here to our chart for another type of battery that's still the same chemistry of nickel metal hydride. So this time it's going to take a little bit more time to set the test up. I got to do them individually. 700 for the first two and 500 for slot 3 and 4 to be fair with the test of the previous test I done. We'll be back to see how well they test. Well, the Thunderbolts did surprisingly well. The AA's honestly are really close to the EBL, but the thing about the Thunderbolts is they're rated for 2200 milliamp hours, so they actually are right at it or above it. So very impressive for the Thunderbolt. The AAA's also done well. The AAA's are rated for 900, and they were really close to that. If we do the quick test on these, there is our milliohm reading of internal resistance on these batteries. And I really don't want to leave the day without looking inside of this charger. So we'll just take a few minutes to look inside this charger and just see what it looks like. And there is not a screw behind that. Oh, not a screw behind that one either. I guess 2 screws in the bottom. Yep, 2 screws in the bottom. So must have a little catch at the top. So just 2 screws removed, and must snap on pretty good. Yep, you can feel the catches here. Yep, there it is, popped off. Yep, catches on the top and the sides. And just 2 screws. Want to gently lift the board up here because I know we have our charging connector in the bottom. We don't want to pull that out. Well, it looks like that's actually a separate board there. You can see that. I might have to remove 2 more screws for that, it seems. The board looks really good though. I see our charging board. And well, look at our thermistor. We got one of our thermistors was turned up and actually not even going into the spot to monitor between the cells. Yes, no way I really could have done that moving the board. It was all the way flat, so I got the goo all over me here, but I'm trying to make sure that lines up and goes back in between the cells. They had good placement for some thermal monitoring there in between the battery, between slot 1 and 2 and then 3 and 4 respectively, but that one actually was turned down to the board. I guess it got bumped during assembly at the factory. That's not good. But here's a look at our board. We got some nice little LEDs there for indication, our charge indication. But one thing I would change is the way they did the light pipe here. It's such a nice design for the LEDs and a nice attempt on the light pipe, and then yet it's just little old bitty, I mean just little small holes at the top, and it's hard to see it from any angle other than straight on. So if I had to change one thing about it, I would make sure that the thermistor was in the right spot for sure. And the next thing is I would definitely change the way that the charge indicator lights here are seen from any other angle than just straight on little dots. Maybe a little slot or something of that nature. But yeah, not a big deal. Just gonna reassemble this now and put the screws back in our charging connector board. and then make sure our thermistor goes in the slot. It all snaps back in. Put the screws back, and I really do like this charger a lot. I like the way the whole design was around that thumb hole. I like the way the micro USB hooks in, and you can even use USB-C to power it. And like I mentioned, you can even take your vehicle charger and charge it. It's automatically portable instead of the one that used to have to hook up to household AC. It's a pretty cool little charger. But yeah, like I say, I would change the way those LED indicators are for you charging. That would be the one thing I would change. So I hope you've enjoyed looking into these rechargeable cells and testing them a little bit today. And at this part of the video, I want to share with you some of the data. So I've taken some time here and put together a chart. For example, this is my first test. I threw the data in here, and then I organized it in a way that I could do my charts. And the very first EBL test, I did these 4 cells. The average here, and at 2800 milliamp hours, I felt like we come up short here. So for no other reason than making sure it wasn't something on my test that wasn't adequate, I brought in some others that were similar. So not apples to apples, but again, averaging here. The next chart I want to show here is taking the best test averages of all 3 of the brands. At the bottom, I just have what their rated capacity is. And this was their best average of 2 cells per test that I did over here. And I averaged them and brought them in. I also did percentages, we'll see in a few minutes. But yeah, I mean, EBL didn't do terrible compared to the others during the test, other than they actually claimed to be 2800, so they claim to be a lot higher. And as we look percentage wise here, based on this test, the others were pretty close to what they claim, but we do see the AA. And I say AA because as we've seen, the AAA will do better here. But the AA in particular here, their best average 2-cell test here, they're shy of 77% of what they claim to be. So we see the end loop, even though these end loops are several years old, they had no trouble over 94% of what they were claimed to be years later. And the new Thunderbolts I bought from Harbor Freight, which I did not expect to do much better, it actually broke 99% of what its rated capacity was. On a few tests we've seen that they actually broke over, as some fell just short. Some actually went over the rated capacity or claimed capacity, which was pretty interesting. Definitely had to share here that we wasn't reaching our claimed capacity at all with the EBLs, no matter how many times I tested them. So I quit wasting time on that and moved on. I had to share the data here. I will share right quick on the AAAs. I didn't test them a whole lot. The AAA is not my main battery I wanted to look at here. The AA is my most used rechargeable battery for me personally, just the capacity typically. But I do want to take time here and put a chart together here for the AAAs. They did do tremendously better, and EBL definitely stands above the rest here. They definitely rated theirs very high, 1100 versus 750 for the end loop and the 900 for the new Thunderbolts I just bought today. And they definitely were really close to what they claim. So when it comes down to percentage, I broke it down here, and your best average that I tested per the set of 2 by brand, and yes, right there with them. I mean they all right there together. Accuracy was within those numbers on each test, just a percent or 2 apart. So they all did very good, and a high rated percentage test versus claimed on the AAAs, and what seemed to be kind of a high number for the AAA. EBL actually did deliver over 94% of what they claim. Really quick, I want to go with the resistance test here, the QT test on this Opus tester that we have, and that's just simply taking the resistance, and this will be in milliohms. So the internal resistance, just how capable it is to output the power and current when you need it. And I did several data points on this and collected the best internal resistance measurements here. And we come up with 194 average on EBL for internal resistance, 97.5 for inner loop, and 120 for Thunderbolt. So anything under 200 for double A's I consider good and workable for me. Some was a little over, some was under, but overall I know that resistance test isn't perfect, but it just gives me, especially when you average it out and do multiple tests, it gives you a good idea. I think I've shown in videos in the past, when it starts going really high, you know you're having some battery issues, so it's a good indicator. Not a rule, but just a good indicator. And really quick here, let's just look at weight. If weight matters to you, it matters very little to me, but I did take time to weigh these batteries. And these nickel metal hydrides here, I put them on the chart by themselves, and the EBL and the Thunderbolt were identical, 27.4, and Luke come in 26.4. And you can see this does follow the capacity, the true output capacity we tested very well, as the EBL and Thunderbolt claimed to be different but tested really similar. And Luke was about what it claimed to be, but it was a lower capacity battery, and it reflects that. And just as a comparison, if you'd like to see it, I did some AA alkalines and weighed those. Our Duracell was 23.9, our Amazon Basics 23.5, and a GP alkaline was 23.2. So just to give you an idea there. And then I also did a chart showing kind of all these together, starting with the nickel metal hydride as shown on the first chart. And then we talked about our alkalines, see how they are lighter. And then just for comparison, I threw in a 18650 2000 milliamp hour cell. A lot of capacity in this cell here, but just to show you the weight difference per capacity, and that's of course a 4.2 volt max cell there. But I hope you enjoyed this video today, looking into these EBL rechargeable batteries that they sent. I do appreciate them sending them in, and I'm going to do as accurate and honest test as I can do on them. I wasn't real happy with the AA capacity, but if they just would have rated it a little bit lower, I would have seen no issue with it. As I mentioned, I really do like the charger with the EBL. So hopefully you can take this data and decide for yourself which batteries, especially what price point that you have, or what sale may be going on or promotion at the time of your purchase. But hopefully this will shed some light on the output capacities and what to expect. If you did find this video helpful, please like, share, and subscribe. I'll have some links down in the description for some of these items, as well as some other tools I find very helpful on my bench. Some of those links will be affiliate links, and any of them you click on, it really does help support the channel, and I greatly appreciate it. So thanks so much for watching, and God bless.